Hi, I'm Dan Fuller. I'm a certified water specialist with Kinetico Quality Water of Southwest Idaho. We're an authorized Kinetico dealer, and we do customized water treatment for residential and commercial use. What we do is we come out to your home, test your water, do a plumbing audit, kind of find out what the needs are for water treatment in your home, and custom design a solution for you and for your home. What I'm doing right now is I've hooked up a miniature water softener and dechlorination unit. Right here we have a synthetic carbon resin that takes the chlorine out of the water. And right here is the ion exchange resin, which actually softens the water. So right now, out of your water, I'm making soft chlorine-free water right from your tap. Now obviously our water softener is going to be a little bit different than this that we're going to install here today, but this is going to perform the same function for our purposes. And the reason I'm doing this is I want to get a couple samples of soft chlorine-free water so I can show you the differences between how soft chlorine-free water works and how your water works. You might also be asking why I'm rinsing these vessels a few times before I actually fill them up. And that's because I want your water tests to be your water tests and not the tests of whoever the last person I tested was. So the first test I'm going to do here is your hardness test. And what we're going to do is we're going to determine how much hardness is in your water. Hardness is dissolved calcium and magnesium primarily. In Treasure Valley, it's mostly calcium. And what that does is it builds up on your faucets, in your shower, in your hot water tank, on your skin, your hair, everything else. But before we treat the hardness in the water, we have to know how much hardness is in there. So what I'm going to do is I'm going to take this water sample, I'm going to add a mild acid so we can get a reaction. 5 drops of that. And then I'm going to put this in. And what this is a sulfate-based dye that is going to turn the water a particular color. And what we're looking for is a royal blue color, kind of like this towel. And what we have is a purplish pink color, which means that we have some hardness in the water. What we need to do is we need to add some of this reagent. This is a base to get this to turn blue. For every 1 drop that we get for that to turn blue, that represents 1 grain per gallon of hardness in the water. So we have 4 grains per gallon of hardness in the water. A grain is a measure of weight. 7,000 grains equals a pound. So let me show you real quick what grains looks like. Because 1/7,000th of a pound doesn't make a whole lot of sense. This is just a generic aspirin tablet. This is 5 grains by weight. So there's a little bit less than this per gallon of water in the water here, of obviously calcium, not aspirin. But for our purposes here today, let's assume that we had 5 grains instead of 4, just to make it really easy. There's 3 people in the home. Average American uses 75 gallons of water a day. That gives us about 225 gallons of water per day used in the home. This right here, this aspirin tablet here, or aspirin bottle rather, is 175 5-grain tablets, which is about 850 grains, okay? So in a 3-day period, 4-day period, 3.5 days, we have this much dissolved rock coming into the home, just in the water. And this is what builds up on your showers, on your skin, on your dishes, in your hot water heater, in your dishwasher. This is what a water softener helps remove from the water. This is just 2 glasses filled from the same tap, both vessels rinsed. We're going to show what happens when we put our skin, other things in the water that has chlorine in it. So I'm going to go ahead and stick 4 fingers in one of these glasses, okay, and while I'm talking about it, we'll just let it do its thing. It usually takes about 60 or 90 seconds, and keep in mind here, I have 4 fingers about halfway, about up to the knuckle, in a little tiny bit of cold water, all right? So this is actually pretty conservative compared to what you do when you get in the shower and the water's hot and your pores are open and your whole body is kind of immersed in hot water. Or worse yet, when your kids take a bath and they are literally immersed in hot water. So as we do this, I'm going to put a couple drops of this chlorine indicator in that one there. And what this does is it's just a dye that reacts with the chlorine. You can see what's happening. It's turning the water a kind of a yellowish color. As I stir it up a little bit, you'll see a little bit better. This is very similar to what you use when you test the chlorine levels in a swimming pool. Okay? So that's just letting us know that there's a significant amount of chlorine in the water. I'm going to pull my fingers out of this one, and then we're going to put, again, 5 drops in that one. And see what happens. We can stir it up a little bit. Nothing's happening because all that chlorine is in my skin now. All the chlorine that we see in this one, we had the same amount of chlorine in here, it's all in my skin. And chlorine is pretty abrasive with your skin. When you get out of a chlorinated swimming pool, the first thing they tell you to do is shower. Rinse all that chlorine off. Unfortunately, most of us get in a chlorine-filled shower to rinse the chlorine off of our skin from the chlorine-filled swimming pool. All right, so what we're going to do now, we're actually going to make some tea. Because everybody that I know, most people I know, drink either tea or coffee. Both tea and coffee are about 98% water. But what most people don't realize is that the quality of the water that you use drastically affects the quality of the tea or the coffee that you're making. So here we have regular tap water. This is Nampa tap water. It's got hardness, it's got chlorine, it's got a whole bunch of other stuff in it. It typically measures around 200 to 250 parts per million of total dissolved solids. What that means is 250 parts of stuff in your water that's not water. So it's not just water, okay? It's water with stuff in it. This here is our Kinetico drinking water that our K5 drinking water station will produce. And what this is it's water. It has a TDS, or total dissolved solid count, of 0 parts per million, meaning it is just water. So we heated both of these up in the microwave simultaneously for about 75 seconds. And right here we just have some orange Lipton tea. And what we're going to do is we're going to put the tea in, and we're going to let both of these just steep for a minute. All right. Now, if you know anything about tea, you know that the tannic acid in the tea actually reacts with the water, creating the tea flavor, the tea aroma, all that good stuff, okay? This is a light tea, not a black tea. I think it's actually a green tea, okay? So it's supposed to be a lighter color. As you can see by looking at these, this one is significantly lighter in color than this one. We're going to let those steep for a minute, and then we're going to come back and take a look. As you can see, our light tea over here with the Kinetico water, it's got a really nice light tea color to it. This one over here, you can see it's very, very dark. It's supposed to be a light tea color. And in the tea bag itself, I mean, you can see the tea bag in the water pretty drastically. There's a film built up in this one on top that we can't see real well on the camera, but we can see it here. There's a little bit of a film here, and what is happening is the tannic acid was actually attracted to all the stuff that's in the water. And if we were to smell this water or this tea or even taste it, we would notice that we're getting a very, very full, rich aroma of the tea from this one here. And this one here kind of smells a little swampy. I don't know if that's a really good word, but you don't really get the full effect of the tea. You're getting a little bit of tea mixed in with all the stuff that's in the water. What we're going to do now is we're going to show you how soap reacts differently with different types of water. Here we have the regular Nampa City tap water. Just comes straight out of the tap with some hardness and chlorine in it and other types of minerals. This here is run through our miniature water softener, removing the chlorine and the hardness. And what we're really looking at today is how the hardness affects things. So this and this are both soft water that we made right from the tap, the same tap that this water came from. This is pure liquid soap. This has no phosphates, no detergents. It's very similar to what you would find if you went into a hospital and the doctor was scrubbing up right before surgery. Obviously, they don't want a whole bunch of aggressive chemicals on their hands when they go in to operate on somebody. It's the same type of soap. Okay, so what I'm going to do is I'm going to put 3 drops of this soap in each one of these flasks. And then we're going to take one of the soft and set it off to the side. We're going to take the hard and the soft. I'm going to shake these up. And we're going to see which one gets more soap, more suds. So if you look at them, you can obviously see there's a big difference. This one here, we have the soft water, lots and lots of suds, and the water underneath the suds is clear. There's some oxygen in there because I just shook it up, but if we let that sit for a second, it's going to be very, very clean, clear water, okay? This here is the hard water, and you see we don't have any suds, nothing at all. On top, we actually have a residue, and what's happening is the soap is attaching itself to the calcium, the hardness that's in the water, preventing the soap from actually creating suds, which is what cleans things. And underneath, we have just looks like dirty water, right? Because we have a lot of stuff in our water that's not water, and the soap is revealing that. So what your soap manufacturers will tell you is, well, if we don't have any suds, add more soap. So we got 3 drops in there now, let's double it. Put in 3 more drops. Shake it. See if we can get some suds. Got a couple suds there for a second, but they're gone. And you see now the film on top, the scuzziness, as some people have called it, is actually a little bit worse. And look what's happening to the water. It's getting even worse than it was before. But we still don't have any suds, so we're still not getting anything clean if we use this water to clean anything. So let's add some more soap. So now we have 12 drops of soap in there, as opposed to 3 in this one. So 4 times the amount of soap. Shake it up. Now we're finally getting some suds. Not a lot, but we have a little bit of suds that are staying. Not a whole bunch. So I think we need to add a little bit more. So we got another 6 drops in there. Now we have 6 times the amount of soap in this container as we have in this one. Now we have some cleaning power. Got a little bit of suds, not a lot. In fact, let's shake that and see if we can get more. Well, a little bit more, but still not as much as this. And keep in mind, I haven't even shook that up since the initial shake. So we have a little bit of cleaning power on this one, not as much as this. But take a look at the water and ask yourself, which one of these would I rather wash my dishes in? Or my kids? Or my hair? Or anything? It's impossible to get things clean using dirty water, even with soap. This is what cleans stuff. Now you may be asking, why 3 flasks? Why 2 soft? And the reason is I'm going to use this third one here to debunk a common myth about water treatment. The myth goes something like this. A little bit of hardness in a little bit of hard water and a lot of soft water is not a big deal, okay? Kinetico systems guarantee 0 grains of hardness in the water, which means soft water. The national standard is anything less than 1 grain of hardness is considered soft because most systems will always leave a little bit of residual hardness in there. What happens more often than not is, let's say we have a 40-gallon water tank, hot water heater, and if 5 milliliters of water is representative of a gallon, we have 200 milliliters in this water, or in this flask. That means we have a representative amount of 40 gallons of soft water right here with the suds. This is 5 milliliters of the regular tap water, the hard water. So the myth goes, if I get a gallon of hard water in with my 40 gallons of soft water, it's not a big deal. It's just a little bit. But watch what happens when I pour 1 gallon into 40. Immediately you can see the soap just attacked the hardness that I poured in there, even though it's just a little bit, and our suds are almost gone. Now if I shake it up, I've got a little bit of suds, not a lot, but a little bit. But look what's happening to the water now. That little bit of hardness in there is causing our water to get dirty. It's actually, the soap is just revealing the dirtiness of the water. We asked between this one and this one, which one you'd rather use. Now let's ask a little bit more complex question. Still kind of a dumb question, but between these two, which would you rather use? This or this? I think most people would say this. But between these two, again, I'll shake this up. Keep in mind I have not shook this since the initial shake. Would you rather use this or this to clean your home and family?